Hello everyone, welcome to this session, Kubernetes native or not, when to ditch your traditional CI/CD server. My name is Dewan Ahmed and I'm a developer advocate at IBM. I have worked with Kubernetes and Tecton over the last year or so. So before that, I started off as a backend developer. Then I worked as a QA. I moved into consulting. So I have had experience with working on different sets of QA tool, DevOps tools, CI/CD tools. And what I'm really excited to share with you today is a Kubernetes native tool, Tecton. I know we have attendees from all over the globe. I am joining you from Toronto, Canada, and I'm really looking forward to this session as well as the exciting Q&As. So while you're listening to this session, feel free to type your question in the Q&A section and I'll be able to answer as we move forward with this session. In terms of today's agenda, we'll start with the challenges with existing CI/CD tools. Then we'll go over what is Tecton. We'll cover some of the Tecton concepts as well as Tecton sub-projects. Then we have the discussion on when to choose the Kubernetes native CI/CD tool. Finally, we have the demo as well as the Q&A section. But you don't have to wait for your question and answer towards the very end. You can keep asking the questions while you listen to this session. If we look at the current landscape for CI/CD tools, there are a lot. And it's good to have choices, but what happens with choices, there comes fragmentation. And if you're a developer yourself, imagine trying to find out the right CI/CD tool for your need. And if you're having this problem, your customers will have the same problem. They're also torn apart in trying to choose which CI/CD tool would be right for them. And that's where K8s build project actually was spun off as a separate project and called Tecton. So this originally started at Google, but then companies like IBM, Red Hat, CloudBees, and a number of individual contributors came forward and worked on this open source project. So what is Tecton? Tecton provides reusable pieces to build a CI/CD system. So it's completely open source. It runs on Kubernetes and it uses CRDs to extend Kubernetes. Now, if you're new to Kubernetes, you might know the default resources that Kubernetes has to offer, such as pods, deployment, services. So these come by default. But we can also create CRDs, custom resource definitions. So these are a custom resource type that could extend Kubernetes itself. So the Tecton resources are those CRDs. And Tecton is part of CD Foundation. So let me actually show you the website of CD Foundation. So if you have heard about CNCF, CD Foundation is similar, and the goal of CD Foundation is to be a vendor neutral home for popular open source continuous delivery tools. So Tecton is one of the founding members, and you can see there are other tools as part of CD Foundation as well. So let's switch back to the presentation and let's move forward to understanding some of Tecton concepts. So initially, let's consider step. So step is the smallest part of Tecton. And you can think of a step doing one specific execution, let's say an echo, or doing a git clone. So one specific action. Basically, a step is just one container that runs. It runs on the same Kubernetes node, and the steps run serially, so one after the other. If you combine multiple steps, what you get is a task. Now, task could run serially or parallelly. So in the diagram, we could see that the task A finishes and then task B and task C happens in parallel. Now task D does not start until both task B and task C completes. So this task could run on either the same Kubernetes node or different Kubernetes node. And finally, when you have multiple tasks, you have a pipeline. So those are some of the core concepts of Tecton. So we have the smallest unit, which is step, then multiple steps form task, and multiple tasks form a pipeline. Now, if you're coming from an object-oriented background, you might know the concept of a class versus an object. A class is a blueprint on how to create the object. An object is the actual execution or instance of that class. So applying the same concept to Tecton, task and pipeline are those blueprints, so the Java classes. But task run and pipeline run are the actual instances. So if we have a task and a pipeline, inherently they don't do anything. When we have the task run and the pipeline run, that's when the actual execution happens. So Tecton by itself is an umbrella project. So it has multiple projects underneath. So we have the pipelines project, which is the backbone of Tecton. So when we talk about the Tecton controller, so that is a pipelines project. We have triggers, dashboard, TKN, which is a Tecton CLI, catalog, and more. But rather than talking about that, actually let's look at the Tecton GitHub repository. So github.tecton/Tecton Cd is the GitHub repository. And under that, we can go to pipeline. Now, as it says, Tecton Pipeline Project provides Kubernetes-style resources for declaring CI/CD style pipelines. And that's what we need during our demo as well. So installation of the Tecton pipelines itself. The next piece I'd like to highlight is Tecton triggers. So before we had Tecton triggers, when you define your pipeline run, the parameters were static. That means you had to declare beforehand, and those were the values it would use. But what triggers allowed you to do is you could dynamically configure those values. So let's say you do a PR, that PR triggers some sort of trigger on your Tecton pod, and the values from your pull request gets injected via the trigger template into your pipeline run. So I know we haven't covered triggers, and triggers is out of scope for this presentation, but that just to show why triggers project was started. So it's a cool new feature of Tecton. After triggers, let's look at the Tecton CLI. If you're on Mac, it's just one brew command. So a lot of the commands we need to do with Tecton, you can do with kubectl command. But Tecton is a wrapper around that, and Tecton makes some nice abstractions. So you can do some shorthand commands to look at your Tecton resources and do some execution. Tecton, thanks to its contributors, also has a pretty nice dashboard. So let's look at Tecton dashboard, and we will be actually using all those except the triggers during our demo as well. So it will be much clearer then. So there is a Tecton dashboard, and you can see your pipelines, tasks, Tecton resources, all in the dashboard as well. So what I'm really excited to show now is Tekton Catalog. So if you remember when we talk about what Tecton is, so Tecton is an open source framework for defining reusable CI/CD, so creating reusable CI/CD system. So that reusability is core of the Tecton Catalog. So most of the tasks that you might be using in your pipeline might come from Tecton Catalog, because lots of contributors have actually worked on various pieces of tasks that you can just take and reuse in your pipeline. So let's see, you can look at Ansible task, AWS, Azure, GCP, Git clone task, IBM Cloud, so Jib, which is a library for building image for Java. There are a number of them. So the goal is either you take this task, make some minor changes of the parameters you need to pass, or if you don't need a change, you just refer this task directly on your pipeline. So going back to the presentation. So now the question, that was the tagline of this talk, when to choose a Kubernetes native CI/CD server. So I had this discussion with a number of our clients, both big and small clients, small in terms of the volume of the business or the number of people working in the team, and large in terms of maybe the Kubernetes node or number of Kubernetes node or the workload or the number of customers. So where rather than trying to answer first if you need a Kubernetes native CI/CD server or not, do you actually need Kubernetes is the right question. And I understand there's a lot of hype around Kubernetes, and for rightfully so, that it's a tremendously useful tool. But asking yourself if Kubernetes is right for your business is probably the starting point. And you can imagine that if you have multiple Kubernetes cluster and you have some idle clusters, which you can use to host your Kubernetes native CI/CD servers, that might make sense. But are you actually using all those best practices in terms of your application architecture? If you're using microservices-based architecture, if you're running your application in containers. So those are the questions to ask before actually trying to answer if you need a Kubernetes native CI/CD server or not. So we have a table where we compare Kubernetes native CI/CD server versus a traditional CI/CD server. But it really matters if you ask yourself if your application is correctly designed to run on Kubernetes as a bunch of containers. And that will help you move forward to the next question, if it makes sense to use a Kubernetes native CI/CD server or not. So let's look at the comparison. Kubernetes native CI/CD server versus a traditional CI/CD server. So the first point I'll mention is logging and monitoring. So if you're using a traditional CI/CD server, chances are that in order to look to some logs, you have to SSH to some server and get some logs, and maybe you export, there's an auto export of these logs to some systems, but you still have to look at these logs. There might be some further tweaking of maybe taking these logs to some nice dashboard, but that really shows that you need to do some plumbing before you can actually look at these logs in a nice dashboard and make sense of what's going on. Whereas in Kubernetes native CI/CD server like Tecton, it's all CRD. So if you're using a Prometheus or Grafana, those are all looking at different Kubernetes resources or CRDs. And at the end, all it is, it's either a Kubernetes resource or a custom resource definition. So the logging and monitoring is really centralized. One example would be if you're using OpenShift, then you can see all the pods and resources and your pipelines in the built-in dashboard. So it's all in one place natively. You don't need to log into a separate server. The second point is high availability. So for typical Kubernetes, for a typical traditional CI/CD server, high availability is not an option, or it's pretty difficult to achieve where you have to go through multiple setups. For a Kubernetes native CI/CD tool, the platform itself guarantees high availability. So you can do your configuration to ensure HA. So if you have your Kubernetes cluster with HA configured, your Kubernetes native tool, which is Tecton, is on top of that platform. So the platform itself guarantees high availability. The third point is self-healing. So typical Kubernetes, typical CI/CD server might have some retry logic if some process fails, but that is not self-healing per se. Whereas Kubernetes, one of the core usefulness besides its scheduling capability is its self-healing. So if you have your replicas configured, and let's say if you have 3 pods expected and one of the pod goes down, the other pod will spin up within seconds. So the self-healing is really baked in to the system. The final point is most CI/CD server are pre-container era. Now, this is not inherently a bad thing, but it just means that the capability of handling containers and working with, let's say, Docker, or these are all a plugin. So these were all developed later to glue it with the solution. Whereas Tecton or other Kubernetes-native CI/CD servers, their resources run as containers on top of Kubernetes. So they were born inside Kubernetes. So these are the typical comparison. I'm not gonna say it's a real challenge because, again, going back to the last slide, if it makes sense for you that your application, your workload is fine for a traditional CI/CD server, that's the call you have to make. So it's not a silver bullet that everyone needs to jump on the Kubernetes train and Kubernetes CI/CD server. It really matters if you understand that what your application needs, what are the metrics that you're looking for in terms of your application success, and then asking the question of if it's Kubernetes, then if it makes sense for Kubernetes native server or not. All right, so enough talking. Now the exciting part, or more exciting part, so that is the demo. So for demo, I'm using a Kata-Kota-based scenario. And the main reason being that I know a lot of you might want to try out the demo as you're watching this session, and you might not have access to a Kubernetes cluster. So that's why I have added, so you can look at the link on your screen as well, but I also have added the same link at the end of this presentation. So you can watch the recorded session, you can try it on your own. But if you're trying it on your own Kubernetes cluster, then you need to do a couple of configurations. The first step is, if you don't have a external Docker registry and you'd like to use an internal one, this scenario explains how you can install a local container registry, and it has a nice UI as well. So you can do a Helm install or a kubectl apply for those. So the other thing is a Kubernetes dashboard. So you can look at the instruction to how to configure the Kubernetes dashboard. For the application, I'm using a Java Spring-based application, and we're using a specific build tool that is called Canico. So if I go here, this is the tool we're using, Canico. So it doesn't matter that if it's a Java-based application, the idea is pretty similar. So it could just be a Node.js application. All it looks for is the Docker file. So if your application is Dockerized, that should work. Next is we need to have Tecton installed on our Kubernetes cluster. And for that, we need to install the pipeline. So the first installation step is installing the Tecton pipelines. So once we have the Tecton pipelines, next we need to install Tecton Dashboard. All right, so Tecton Dashboard in install, it might take a few minutes for the resources to be up. And then the final piece for Tecton is installing Tecton CLI. So to see if Tecton was actually installed, we could do tkn, and yep, it seems that tkn or Tecton CLI was installed. We could also do kubectl version short, and it shows us the Kubernetes version on this cluster. All right, so next step is actually cloning the repository. So if you want, you can clone this repository, but this is a Node.js app. I have a Java Spring app on my repository, which you can see on the screen. And let's actually go ahead and do a git clone. And let's look at the Tecton files. So the Tecton YAML files are under .tecton folder of this repository. So if I do an ls-la, I can look at all the files. So the first step is to define a Git resource. So we need to tell Tecton where our Git repository is. So let's do vim Git resource. So line number 2, it's a pretty generic YAML file. So you have your AP version, your kind, your metadata, and your spec. So line number 2, in kind, we are mentioning that it's a pipeline resource, that the type is Git. And in line number 11, which is the important line, we're mentioning the location of our Git URL. So let's do a kubectl apply-f Git resource, and we have our Git resource created. Let's see if our Tecton dashboard is up. All right, so our Tecton dashboard is up. It's a very nice UI. Kudos to the team that worked on developing this. So we don't have a pipeline run. We don't have a pipeline. So it's expected that we shouldn't see anything here, but we just created a pipeline resource 25 seconds ago. So we can see that here. All right, so now we have our pipeline resource. Let's look at service account. So the service account actually gets all the permission on this Kubernetes cluster to execute actions. So that's where you need to specify secrets and role binding alongside the service account declarations. So let's look at the service account YAML file. All right. So if you see, there are 3 parts. We're defining the service account, the role, and role binding with all the permissions for this for this particular demo. We don't have any secrets defined for our service account. The reason being, the Git repository we're using is a public repository. The Docker registry where we'll build and push the image is an internal registry. So for neither of these, we need to define a secret. But let me show you a secret file. So let's do a vim docker secret. All right. So in case your Git repository is a private one, or your Docker registry is an external one, you need to define a secret file like that. So this is an example for Docker. So line number 6, it's index.docker.io, but this could be a Git repository. So you need to change line number 6 and mention it, let's say, github.com. The line number 9 and 10 is your Docker username and password. If you're using, let's say, a private Git repository, line number 9 could be Git token, and that would be your GitHub API token. But we're not using that for this demo. The goal was just to show you, in case you have a private Git repository or an external Docker registry, what changes you need to make. All right, so let's do a kubectl apply-f service account. All right, so service account was created. Our role and role bindings were created. We can do tkn tls. So what this shows is it's a CLI to show you or list all the tasks. So same thing we can see from the dashboard. If we go to task, it doesn't show us any tasks. So it's the exact same thing. we don't have any tasks defined yet. So let's look at the task we have. So we have two tasks. One is task build source and the other is task deploy. So let's look at task build source. So on line number 8, we are referring the Git source, the pipeline resource we have created. Line number 11 to 20, we have the parameters defined. And then we're mentioning two steps. One is a list source step, which just does an ls, and then the meat of this task is build and push step. And we can see that it's using the Canico tool. So this task you can very well reuse in your own pipeline without too much modification, maybe some minor modification in the parameters. So let's go ahead and do a kubectl apply-f task build source.yaml. So our first task was created. Since our task was created, we should actually see the first task, tk and tls. So it shows our task was created here, and then it shows on the dashboard as well. So let's do that same process for the second task, kubectl apply-f task deploy. So our two tasks were created, but this is just the task. So as we mentioned, task versus task run, without the instance, nothing actually happens. So I'll pause here and explain the difference between task run and pipeline run. So you might want to use task run when you're just using one single task, and that's it. But typically in a real scenario, you'd be using multiple tasks and you need to put all those tasks within a pipeline. So it makes sense that you actually use a pipeline run to execute all those tasks within a pipeline rather than creating individual task run for each task. So that's kind of a difference when to use task run, when to use pipeline. So traditionally, you will be using pipeline run all the time, because very rarely you'll have a situation where you'll only have one task and you want to do a task run on top of that. All right, so we have our two tasks created. Now let's look at the pipeline file. So this is the file which brings both the tasks together, and the same parameters that we had during our task defined. So line number 10 to 21, we have the same parameters, and line number 4 shows the name of this pipeline, application pipeline. So remember this name because you'll be seeing the same reference in our pipeline run as well. Line number 22 is where we are referring the two tasks. So the first one is build image from source. It shows the resources that this task and pipeline is using, the Git source. And then line number 37 shows the second task, the deploy application. The file initially might seem a bit confusing, but if you look at the file closely, there is a pattern. So the name, the task ref, the run after is an important command, because remember the tasks could run either serially or parallelly. So if you don't specify this run after clause, which is in line number 40, the tasks would happen simultaneously. But you don't want to deploy your application before the application actually gets built and the image would be pushed. So that's why the run after clause mentions that this pipeline would run this task serially, the first one and then the next one. So I was mentioning that the pattern is very similar. So you have the name, you reference a task, you have your params, and you mention which resources you're using. So the YAML file might be large, but then if you're just starting with Tecton, no need to panic, because pretty soon you'll observe a pattern and it's probably just the same process you're copying over and over again, making some minor changes. So let's do kubectl apply-f pipeline.yaml. All right, so pipeline is created and we can actually use the shortcut command tkn pls to show the pipeline was created. So this doesn't show much. So what we can do is tkn p describe and then name of this pipeline. And that should give us a bit more details. So as you can see that the describe command actually shows us which pipeline resource we're using, the different parameters, the two tasks within this pipeline, and if there is any pipeline run associated. So again, we just ran we didn't run the pipeline per se because this is just creation of the pipeline. Pipeline run is the execution, so which we'll do right now. So if we look at the dashboard under pipeline runs, we shouldn't have anything because we actually didn't create a pipeline run. So let's do vim pipeline run. And remember we named our pipeline application pipeline. So you can see in line number 7 in our pipeline run YAML file, we're referring to that same pipeline. One important point is line number 21, where we are specifying the service account. So this is during runtime, Tecton will know that what kind of permission it has to execute various actions. So depending on what kind of secret is attached to this service account, what kind of role, what kind of role binding, Tecton will be able to perform those actions. So this is very important, which service account you're using. So in my experience, most of the Tecton issues I had, I was probably using the wrong service account, or the service account I was using did not have the right permission. So if you're working with Tecton and you're stuck with some permission issues, checking with the service account probably is one of the first steps. So again, the parameters within pipeline run actually provide the runtime parameters. So this is where you supply these parameters. And what I mentioned during the trigger is for triggers, these parameters would be supplied dynamically from any of the external events. For example, GitHub PR. The values here are hard-coded, but typically for an actual project, you might have some config file where these values are, or some environment where you're getting these values. All right, so let's do a kubectl apply-f pipeline run, and our pipeline run is created. So this is where the actual process should happen of building the image, pushing that the image to an image registry and all the good stuff. So fingers crossed, and let's look at that. So tkn prls. So it shows our pipeline run is running, but we can actually use the dashboard. So let's go to the dashboard and we can see the application pipeline run. This particular pipeline run was started 32 seconds ago, and we can go inside to look at the logs in more details. So the first task, which is build image from source, is running. First step within that task, list source, was completed. So that basically does an ls, not much, but the main step is the build and push step. So if you see the retrieving image manifest from Ubuntu, all these are coming from the Docker file. So let's look at the Docker file, and we're doing a base image from Ubuntu latest. And that's why you're seeing these archive Ubuntu, a lot of Ubuntu commands. All right, so it might take a while. Let's use the CLI to see if we can have a similar view. So let's do tkn pr logs application pipeline run, if there's no typo. Okay, so initially the CLI would show you the same logs as you're seeing on the web dashboard, but it takes some time to load. So if you're not seeing anything, give it some time and it's gonna load. And we're seeing that the build and push step is still running. And let's look at the dashboard. So the build and push is actually completed. Let's look at the bottom of this log. All right, so we can see this is Java jar command. So let's look at the internal registry. And we can see one image. So there was no image before. I didn't get creative with the name, so just named it the app. 50 seconds ago, this image was pushed here. The size tells you that it's a typical Java image. We could also see the command it ran. All right, so the application was built and the image was pushed, but we have the second task, which is deploy application. So the application was actually deployed as well on the Kubernetes cluster. So we can look at the Kubernetes dashboard. Let's look at the deployment. And we need the token. So this is specifically for this environment. If you have your own Kubernetes cluster, you don't need to do this step. All right, so we can see this particular deployment. It was deployed a minute ago. 3 out of 3 pods are running. And let's see our running application. And we can see hello world, which is the success point for any demo. So we have a hello world, but I think we can do even better. Let's do name equals J4K. Wow, hello J4K. All right, so that concludes the demo. So let's recap what we did in this demo and what we learned in the entire session. So for this particular demo, we had our source code in GitHub, which was a simple hello world Java string application. We wanted to build our application source code, create a Docker image and push the image in our Docker registry, and then deploy that application on a Kubernetes cluster. So Tecton allowed all these things to happen. So your GitHub code and then your Docker registry and your Kubernetes cluster. So Tecton is in the middle. So Tecton is installed on the same Kubernetes cluster. Tecton initially we installed the tasks for Tecton. We created the pipeline and we created the pipeline run. We already defined the pipeline run. We already defined the pipeline resources for Tecton, and we also defined the service account, which showed us the role binding, and if you need any secrets. So with all that, we applied all those files and our 2 tasks were executed. One was the build source from image, build image from source, and then one was deploying the application. So that was a simple demo for Tecton, but the whole concept of Kubernetes-native CI/CD server or not, we explored various tools out there and what are the challenges that our customers are facing. We understood that before answering the question about Kubernetes native CI/CD server or not, we have to answer the question of Kubernetes or not. And then we had a table where we compared various advantages. For example, you have all your logs centralized. You have your HA, your fault tolerance, all those benefits of using Kubernetes native CI/CD server or not. So finally, I'd like to point you to the resources if you want to get started with Tecton. The website is tecton.dev, and this is a pretty nice website where you can look at all the documentation, the GitHub link, and I believe there are some interactive tutorials here as well. Then you can look at the public Slack channel, so tectoncd.slack.com, and the community is very active. So if you have any question, feel free to ask on Slack as well. Feel free to follow their Twitter handle as well at tectoncd. And then finally, I have done a shortening of the GitHub Catalog scenario we just did in this demo. So feel free to get started with Tecton, and I'd like to connect with all of you. We understand that it's a virtual conference, so we're missing that face-to-face interaction. But regardless, I'd definitely love to connect with you, whether if you're active on LinkedIn or Twitter. Let me know what you thought of this session. And then if you have any further question, please don't hesitate to reach out to me there. I wish you all the best, and looking forward to meeting with you someday in person as well. Thank you.